I think the biggest shift has been the way, and we were briefly chatting about this, it's the way we're viewing mathematics. So if we're viewing mathematics as a way of thinking about things, then we're going to take that knowledge and understanding of those math concepts. So for example, with that example that we shared, we talked about perimeter. So you were using your knowledge and understanding of perimeter, of how perimeter relates to area. You were using your understanding of, or you were reflecting on your experiences and with regards to length and width, and you were taking all of that, and then you were presented with a different context, and then you had to go through those thinking skills. Like one of the first things you needed to do was you needed to interpret the problem. So what is the problem even asking me to do? What connections am I making to previous experiences that are going to help me do that? How am I reflecting on what I already know? So, and hence all the different skills. So,
well, I was thinking also when you're first looking at a problem or a task or a question, that one of the most key skills is to be able to analyze the question. So deconstruct it and take it apart so that children or learners can reflect on what it is that the problem is or the question is asking. And so we don't really think about the process of analysis or analyzing through that lens, right? So how do we to analyze means to take apart. So how do we take apart the question? You know, what are the key words that we need to pay attention to? Then they have to think about making judgments around strategies that they're going to use to tackle that question. So now they have to use their judgment in terms of which strategy is going to be best to help them answer that question. So there's so many invisible actions that the students have to take before they can even tackle the question, and then when they're tackling, there's a thinking process, and so I think it's really important that students understand when they're shifting from one skill to the next, because we talk about thinking, which is this huge umbrella, but yet what's the difference between when I'm making a connection to inferring or interpreting and to actually analyze and evaluate and just working through those different skills. But students need to be aware of those mental actions that's going to help them approach those rich, mathematical tasks.
And it's so interesting to me because you still need that skill set or that understanding in all subjects. And if math is a great vehicle for understanding those concepts really well in a very tangible sense, I think, and then it can be applied to any kind of subject, really.
And
so
we talk about cross-curricular thinking skills, and yet, how often do we pay attention to those skills in the context of mathematics?
Right. So that being said, how do you track then these invisible actions or these processes of thinking, things that are so kind of general? How would you track that in an actual class?
I would say from the literacy lens, which is all our curriculum is grounded in skills. It's modeling what those skills look like in context and being able to name the skills so that students then can engage in reflection. And when we ask them to reflect on strategies that help them best attack that question, they can actually name the skills. So it is about, we refer to it as noticing and naming the learning. And so in order for us to notice it, we have to make it very transparent for our learners as well, so that they can start noticing it in themselves when they're engaging, and they can say, well, I made a connection because last week we looked at another problem focusing on perimeter, and they can start looking at themselves, identifying when those actions, those invisible actions, become visible. So, but it does require, on the educator's part, the modeling, the learning conditions and being very intentional about making those invisible thinking skills visible.
That's kind of the next step, is helping teachers to notice it, but in order for them to notice it, they need to be able to elicit it. So if we're engaging in a learning experience with our students, we have that important job of saying, well, Maria, when have you seen this before? Tell me what this makes you think of. How does it connect to the things that were happening last week, like the things that we did? So as teachers, we need to we're modeling, but we're also asking those questions that are going to elicit that.
So it's that intentionality.
Yeah, the purposeful intentionality.
Yes, that's really key. The focus has to be on the learning process and not when we talked about the teaching for the then, where it was all about getting the right answer and answering the question and focusing on the right answer, as opposed to being able to reflect on the process. So how do I approach this question? How do I approach this task? There's a whole, reflective process that goes with, attacking any task. So
one of the most, when we were working on this journey, the most fun that we had was with our math tasks. And we don't, we're even calling them like math text, because we didn't want to call them problems, because that just sets that whole, reinforces that it sets a tone that math is nothing but problems,
and it's only about
problem solving, and it's not just about problem solving. So one of the most fun things that we had on this journey was when we had our math tasks, the learning experiences, and how were we going to structure them and change the wording to elicit certain behaviors. So when we were, for example, how does this question support inferring and interpreting? And what types of questions would I have to further ask if I didn't see it in the student work, if I was really getting at students naming that thinking skill? And it was really exciting.
And we brainstormed, which is outlined in the book. We brainstormed questions that we could ask students or use on an anchor chart, and also prompts that we could, because we were thinking of our English language learners and students with diverse learning needs. So sometimes they need a thinking stem, and so we provided some concrete examples of questions to help elicit those particular thinking skills, and prompts to help students at least getting them to start thinking about that particular process or that skill.
And then we also captured some of the conversations that we had with the students as well. So their work showed us some things, but the conversations and the things that the students said highlighted other parts of their learning that wasn't evident in just the paper.
Yeah, in the paper we saw we missed a lot. If we just relied on the student response that was captured on
paper,
in their representation on paper, we found that there was a lot of evidence that we missed, and it wasn't until we engaged in conversations with the student, because we wanted to dig deeper, and we basically said, help us understand what you mean by this. And it wasn't until we heard their voice that we thought, wow, they did meet the criteria. So I think, that conversation is really, really important in that assessment process, which is something we knew, but we really realized it when we worked with the students.
And even our learning intentions, when we framed our learning intentions, shifting the language that even we had previously used in the past. So I would have said today we're learning to identify growing patterns. And then to shift that language to we are using the skills of inferring and interpreting to help us make sense of growing patterns. And just that language completely shifted the way we then approached that task with the students. So
We didn't focus it on a particular strand.
no.
It's looking at how can those skills be transferable across all mathematics strands.
So is that something that is this built upon the last book?
We did think at one point that we would write, we would build on the four rules of the new learner, but we decided that that the mathematical thinking was such a focus for us that we wanted to really unpack what we believe are those essential thinking skills. So in moving math, we basically deconstructed each of those skills. But having said that, the four rules of the new learner provide a conceptual framework of which the thinking skills are such an integral part of that framework, which is why we felt that we needed to deconstruct it with concrete examples and evidence of student learning. So they do support each other, but it's not like it's a continuation of.
So we recognize that students need knowledge and understanding, and we recognize they need to be able to apply their knowledge and understanding. We realize that they need to be able to communicate their understanding and their thinking. But we also know that we need to be able to assess their thinking, and we felt that, wow, we really need to make sense of what thinking is. Like, it's a word that's used so loosely and so commonly. Like, we use it. I think one of the things we talked about, I think Webster's dictionary says it's one of the most commonly used words in the English language. But we felt we needed to make sense of it to support the teaching and learning of math. So hence our journey.
And there was there was a sense of urgency because in our current roles in our board, we have a board perspective, and board-wide evidence of student learning would have told us that there's a huge need to shift how we approach the teaching and learning of mathematics. And I started to make connections to one of the presentations today that looked at cultivating leaders. And my connection was that, we've been focusing on the skills. I think about math skills, like you said, the algorithms, the rules and procedures. But what makes a complete mathematical learner? In math, you have the skills plus the content. And now you need the will, because we have students that don't see themselves as being good at mathematics, and teachers who also feel that
I can't influence. I can't help my students. I don't. It's not a strength for me.
We also realize in both of our journeys, in both of the books, that putting it in that language, that will is really important. Is how can we engage students? How can we build that sense of self-efficacy so that they believe in themselves, that they can engage in rich mathematical learning experiences? It's been a wonderful journey for us to engage, because this really started off as an inquiry for us, a professional inquiry, because we wanted to really look at how we could leverage what we learned about literacy to support numeracy development. So it's been wonderful for us to engage in deep conversation and thinking and really looking at, making sense of what we learned about literacy and applying it to numeracy. And so we found so much alignment, and that the two do support each other. But the journey and the process for us was very, very empowering. And then, of course, working with educators and our students and trying, some of the learning tasks. So it's been a big learning for us.
Well, even when we first started having our conversations, we talked about language, for example, in mathematics, and then we made connections between the two curricula. So that was like, okay, well, that's the basis for knowledge and understanding and communication. So then when we started to talk about literacy, that just naturally led us to, well, that's numeracy. And is it really different? And we It's like, no, it isn't different. So the language and the mathematics might be different because the concepts and skills are a little bit different. But are those skills to support literacy development and numeracy development very different? And they weren't. So those cross-curricular thinking skills that helped everyone see themselves as teachers of literacy, we thought, well, we've got to be able to build upon that and really focus on numeracy, not just mathematics, not just the strands, recognizing that that is a part of our curriculum and it's not going away, but how we approach the curriculum. So,
and what we do with the tasks.
and what we do.
Because it's not about, you know, providing more and more examples of rich tasks, or we call them mathematical texts, but it's working with our educators so that we're really looking at the purpose and why is it that we're putting these mathematical texts in front of our learners, and what are we doing with them, right? So it's working more deeply with each mathematical text, and so that students have multiple entry points. So that's been very powerful learning as well. How do we foster and help develop that? We call in reading, we say the reading habit, but in mathematics, it's how do we help students adopt that mathematics habit so that they're trying, they're exploring, they're willing to take those risks, right? So and they're okay with making mistakes, and they see themselves, because if we're just focused on the right answer, then we're missing maybe some powerful thinking that has gone into the process.
Right.